5.1.5. For which values of x is f of x less than or equal to g of x? Now, just like with the previous one, this is actually the question where we really struggle, because now we need to compare the two different graphs. And the trick here is to know again that these inequality signs basically mean above and below. Like with the previous one, 5.1.4, this basically says where does my parabola, where is it positive? In other words, where is it above the x-axis? Remember we said that our x-axis was our point of reference to see where my graph is positive and where it is negative. So in other words, where we saw that our graph is positive for these values, that is basically the part of the graph where the parabola is above the x-axis. Okay, these parts over here, because between -3 and 3, my parabola is below the x-axis, right? So it's this piece over here. So now applying that same thinking to the two graphs, comparing the two graphs. In other words, for which values of x, once again, is my parabola lying below my straight line? Because less than means below. Remember, less than 0 means below the x-axis. Now, where is f of x less than or equal to g of x? So now we're not using our x-axis as a point of reference anymore. We are literally checking to see between which x values, or for which x values is my parabola lying underneath my straight line. Underneath and above, I don't think it's too difficult to comprehend and orientate yourself on the coordinate plane here. If I look at my graph or graphs, if I look at this point over here and I look at this point over here, I can see for that between, so at whatever point that is, whatever x value that is, and this x value, which is very clear, it's 3, between those two x values, my straight line is lying above my parabola. So let's just see what that means. Above, remember, when we are talking about f of x, let's just write it down first quickly, f of x less than or equal to g of x. So don't be confused by the fact that there's now an equal sign as well. That just means that for whatever values of x you're going to choose, you are going to include, in other words, it will be an equal sign in your solution as well. It will be included, not like here in 5.1.4 where you did not include -3. So -3 in this solution is not included because there's no equal sign. Same here. Now in this one, we will have an inclusive sign or symbol, meaning we're going to have the equal sign added as well. So this means for which values of x is f of x, my parabola, lying below my straight line? Different way of saying that, for which values of x are my y values for my parabola less than or equal to my y values of my straight line? Okay, so let's see what that looks like. So when we compare the two graphs, f of x and g of x, in other words, the straight line and the parabola, our reference points are going to be those points of intersection. In other words, where do these two graphs intersect? They intersect here and there. Now, you'll agree with me if I say that with reference to these points over here, these intersection points, between those points and on either side of those points, my two graphs are going to behave differently. In other words, for one section of this diagram, the straight line will be lying above the parabola, and for certain portions or sections of this diagram, my parabola will be lying above the straight line, and vice versa. So let's see where this is. If I look at -3 and 3, just as a note here, I can't use -3 as a reference point because there's no intersection happening at x equals -3, right? The intersection is here, right? So that value, like I said earlier, we're going to find out what this value is over here. Our intersection point here is just coincidentally on the x-axis, and it's one of the roots and also, of course, the x-intercept of the straight line. So that is why 3 will be a reference point for us to see where the two graphs or how they are behaving in relation to each other, but not this one, right? So we need to find out what is the coordinates actually, in more importantly, what's the x value here, so we can see how we are going to write out our inequality. Now, before we do that, it is important that you are able to see where the graphs lie above and below each other, and for what intervals, okay, from where to where. So I'm going to say that this portion of the parabola here, this portion of my parabola lies below the straight line, because you can see the straight line going down here, and this part of the parabola, in other words here, this region is lying below the straight line. Okay, now how else can I show this? Let's choose an x value in that region. So the region I'm talking about, let's just point or pinpoint. So we know we need to find out what is this point over here. That's a point of intersection, and we're going to make this red as well here. So here we know that this is 3 and 0. We of course need to know what is this. In other words, what is this x value over here, because that is going to be our region. We're going to have a region between this value over here. Remember, this point here is not -3. -3 is over here. It's just the number that's written big over here. In fact, for the purpose of this question, I'm going to move this number to the other side just to avoid confusion. Right, so now we can clearly see that this point over here, there's some x value here that's going to serve as our sort of boundary or reference point, just like this point over here, which is 3. So from this x value over here, our parabola, this portion here, is lying below the straight line all the way. At this point here, our parabola is also lying below. In fact, this turning point over here is a perfect point to illustrate this as an example. My f of x value, in other words, my y value for the parabola at this turning point here is -9. We know this already. Now, at this very same point, where is my straight line? My straight line is at 6, +6, and obviously 6 as a y value is much greater than -9 as a y value. So that is a point of the parabola where f of x is less than g of x. The equal to part, of course, the equal to part comes in is those 2 points where these two graphs intersect, right? That is why we're going to include those 2 points, right? So it is only at those 2 points where they are equal, and that is why when we answer this question, the equal sign is referring to those intersection points where the two graphs meet. They are exactly equal at that point. So we'll find out in a moment how to work out this x value. But what's important here is that you see that this part of the parabola, all the way up to here, lies below the straight line. Okay, I'm not going to highlight the straight line. You can look at the straight line for this part and just look at the highlighted part of the parabola right now, which is becoming 10 parabolas, but this part of the parabola is lying below my straight line, only for that portion. Now, what happens once we cross 3? Once I cross 3, look at what's happening. As we've seen with the previous question, my parabola now is going, like we know, it's now positive, it's going upward. And from this point 3, my straight line is now, it's always been decreasing, but now it's lying below the x-axis now. Notice that my parabola, like we said in our previous answer, it is positive for x greater than 3. So from 3 onwards, my parabola has positive y values. But from 3 onwards also, my straight line is now way with reference to the x-axis. It is now below the x-axis. So these values for my y values here for my straight line from 3 is negative, and for my parabola it's positive. So my y values for my parabola cannot still be negative and less than my straight line, because the graph doesn't show that. And in terms of my y values, that is very obvious and clear. And also in terms of looking at it from a diagram point of view, my diagram or my graph for my parabola is above the straight line now. Here, the straight line is no longer above the parabola, it is actually below. So as an example, if I choose an x value here, whatever the x value is, if I trace out a corresponding y value, it will be somewhere up here, obviously and clearly positive y value. If I do take the same x value and find what corresponding y value will this be for the straight line, it is obviously a negative y value, right? So, and that of course will be true for every y value beyond x equal to 3 for the straight line, and of course for the parabola. So here we can see clearly that my parabola is positive beyond x equals 3, but my straight line is negative beyond x equals 3. And again here, I'm actually not, because there wasn't enough space for me to continue with the graph onwards here. The same can be proven on the left side of this intersection point. So what I've just explained over here from x equals 3 that way for the parabola and the straight line will be true to the left of this intersection point over here. But the question is not where is my parabola positive and greater than my straight line. It is where is it less than my straight line. So let's come back to this region over here. This is the region where my parabola is less than my straight line. And in other words, that means, like we saw now, that my y values for my parabola in this region is less than my y values for my straight line in that same region. So let's try and prove that. If I choose x equals, let's say -2 somewhere over here, and I find a y value for my parabola, it will have a corresponding y value that's negative. But for that same x value, if I find the corresponding y value for my straight line, it clearly is some positive value here. The same will be true there, but for my parabola up to this point 3 or -3, my parabola will have negative values. But now you say, okay, but if your boundary reference point is here, what happens between -3 and this number, which we'll get to in a moment? Well, it is still true that my y values for my parabola is less than my straight line. If I choose this point before I get there, if I choose this point, I've got some y value for my parabola, which is there. But for the straight line from that same x value, I'm going to get a y value somewhere up here. So my y values for my straight line is still greater than my y values for my parabola. So what all of this means is we just need to be able to see where does my straight line in this particular question lie above my parabola. In other words, where does my parabola lie below my straight line? And hopefully the more you do this, the more you'll be able to see where those regions are. Right? So looking at it without using values, this part of my parabola, like we said earlier, is the part that lies below the straight line. Okay, so I went through all of that explanation and detail just to try and drive the point home. But when you do this, you don't need to prove all of those. I mean, this was just to show you that any y value for the parabola from this point onwards all the way down this portion, every y value for this portion of parabola will be less than the y value for the straight line in that same region. Okay, that's what it means. So if I just go to this x value over here, my y value, my corresponding y value will be some negative value over here. But for that same x value, what will my y value be for the straight line? It's going to be a positive value. So again, my y value lies above my parabola's y value. And the same will be true here, because my y value is positive. but my corresponding y value for that same x value for my parabola is negative. Okay, so this is, and that stops at 3. Okay, and it stops here. It doesn't stop at -3 as we saw, because the graphs are not intersecting here. So our intersection points is where we look at where are these graphs lying above and below each other. I know that I'm going to need this x value here because that's my boundary, and that's my other boundary, or my reference points. So I know that the area where my y values for my parabola is less than or equal to my y values for my straight line is x greater than or equal to this number over here, and less than or equal to this number over here, which is 3. So it's this region here that is our solution. Now, how do I get this x value? Because I don't have it. Well, what's happening at this x value? At this x value, my two graphs are intersecting. What does it mean if my two graphs are intersecting? It means that at that intersection point, f of x is equal to g of x. In other words, my two graphs are equal. What are my two graphs? Well, it's that, and it's that. So if f of x is equal to g of x, it means that this expression here and that expression here are equal to each other. So if I put them equal to each other, I can then solve an equation, and I will be solving an equation for x, because if I put these two expressions equal to each other, I will only have x as my unknown. So that's what I'm going to do first here. So this is not the solution yet, but this is part of the solution, or leading up to the solution. We need to know where is f of x equal to g of x, because we need those x values as our reference points, right? So we have the one. We have the one here, it is x equal to 3, but we don't have this one, and that is why we're going to, so what's going to happen is we're going to expect our solution to this problem is going to have two answers, because, not that one, sorry, we're going to have this one and that one, because there's two intersection points. So we're expecting two solutions, and if we take f of x and put it equal to g of x, we can see, of course, that this will result in some kind of quadratic. So in other words, there must be two x values as our solution. So let's see how this works out. I'm going to have x squared, I'll have plus 2x, I'll have negative 9 minus 6 will give us negative 15, all equal to 0. So I just brought everything over to the left-hand side. I'm going to factorize now. So that's x and x. And our factors for 15 to give us 2, I think it will be 5 and 3. So it will be 5 and 3, and now we just need to choose our signs properly. It's going to be a positive middle term, positive 2. So I need my answer to be a positive 2. So it means my 5 will be positive and my 3 will be negative. Because if I multiply this out, I'll get 5x. If I multiply that out, I get negative 3x. And 5x plus negative 3x is positive 2x. So that is correct. So this means x equals negative 5 or x equals 3. Now, like we said, we expected one of our solutions to be 3 because we could see that on the graph. So the solution that we are looking for is negative 5. So that number that was missing here was negative 5. And it makes sense because negative 5 is to the left of negative 3. So there's more to that side. Right, so our solution for this question here, because this is the original question that we're busy with, where is f of x, or for which values of x is my f of x less than g of x? I'll fill in the answer over here since we prompted that here already. It is going to be, remember, it's lying between two values, so it's a region or a set of x values between two numbers. That numbers is negative 5 and 3. So I'm going to have my inequality look like this. I'll have negative 5. I'll have x, so x greater than or equal to negative 5, but less than or equal to 3. That is my answer. That is the region of x values, or the set of x values lying between negative 5 and 3, where my parabola lies below my straight line. So I hope that explanation helped. I'm not sure if, well, maybe some of you felt that it was a bit of overkill. Hopefully the overkill was enough to help those of you who really struggles to see this. Maybe watch it a few times, go over it slowly, and try and do it yourself as well, just to try and really just solidify that concept. And the more you try to answer these questions, in fact, you should, in your textbooks and in the worksheets that you have, there are quite a few of these types of questions, and I would strongly advise that you go and do a question like this, do the whole thing, and especially try to answer these guys, so you can just get some exercise and practice looking at a graph and try to see those inequalities. Oh, if you are finding these videos helpful, you feel that it's adding value to your learning of mathematics, feel free to share it with others who you think will benefit from it. And consider liking the video, consider subscribing. It really does help the channel. And hope to see you in the next one.